All right, so 9.1, solving equations. And so an equation is just a statement that says that two algebraic expressions are equal. So an example of that is x plus 5 equal to 7. All right. Erase some of this stuff. So your solution is a value that will make an equation true. So a value or values that will make an equation true. So x equal 2 would be the solution for this equation. And that's why I had this line going up here. Because when I plug in 2, that will create my true statement. 2 plus 5 is equal to 7. So your solution will be a value or values that will make your equation true. So whenever you're talking about solving, you should be asking the question, when is this statement true? And in this case, when is x plus 5 equal to 7? And you know, the answer is when x is equal to 2. All right.
What number is this again? Like the. Can you scroll back up?
Something like that.
Yeah. Oh, I see it. 9.1. Okay. Never mind.
Oh, okay. Yeah, that's all that was up there. Yeah, just 9.1. Sorry. I didn't know you wanted me to go that high. Sorry about that. All right. Anything else before we go down? Got it done with solution. Okay. So we'll be solving by what I call opposite operations. So remember, our goal is to solve for x. We want to get x by itself. So we need to undo what's being done to x. We have, if we go back to that equation of x plus 5 equal to 7, addition and subtraction are opposite operations. They undo what the other one does. Multiplication and division undo what the other one does. So if I have x plus 5 equal to 7, in order to undo the addition of 5, I will subtract 5. Plus 5 and negative 5 will cancel. Now, we have our equation that's split up into two sides. We have the left side of the equal sign and the right side of the equal sign. And the reason why that is important is because whatever you do to the left side, you have to do to the right side in order to keep your equivalency. So if I subtract 5 from both sides, from one side, I have to subtract 5 from the other side in order to keep that equivalency. So the negative 5 and positive 5 cancels on the left. 7 minus 5 is the 2 on the right. And that's how I have my solution of x equal to 2. So that's the foundation of what you will be doing as far as solving is concerned. You will be using opposite operations to undo what's being done to your variable so you can get your variable by itself. Once you get your variable by itself, whatever's on the other side of that equation is your solution. All right. Questions on that? All right. So just a few more examples of one-step solutions to your equations or one-step equations in order to get to your solutions. We have y minus 10 equal to 20, and we want to solve for y Then we will add 10 to both sides of the equal sign, both sides of your equation. 10 cancels. Y is equal to 30. We have 5a equal to 13. So that's 5 times a equal to 13. So we will divide both sides by 5. 5's cancel. A is equal to 13 over 5. You don't have to take that to a decimal or write it as a mixed number. 13 over 5 is fine. If it can reduce, then you are expected to do that. I think, yep, I have that right here. You know, in other words, if I had the example of 4 over 6 as an answer, you are expected to break that down. You know, 2's cancel, and that'll leave you with just 2/3 as your answer. So you are expected to reduce your fraction, but you don't have to take it to a decimal or take it to a mixed number unless something in directions specifically tell you to do so. So leaving it as 13 over 5 is fine. All right, then for this next one, we have x divided by 9 equal to 11. So since that's dividing by 9, we will multiply both sides by 9. 9's cancel. X is equal to 99. So before we add anything else to it, add a little more to it, any questions on what we've done up to this point? And what I could have did here was just say sample. All right, so let's look at the next one. All right, so the next one we have is 2x plus 1 equal to 7. And so we want to solve for x. We want to get x by itself. So the most efficient move for us to do so is to subtract 1 from both sides. Now, if you wanted, you could have divided both sides by 2, but that would have caused for you to have fractions involved where you don't need it. So the best move is to move that 1 first. 1's cancel on the left, so that leaves me with just 2x on the left, and then 7 minus 1 is 6 on the right. So now to solve for x, I have 2 times x. So I need to divide by 2. 2's cancel. X is equal to 3. All right, questions? Any questions? All right, next one we have 5x plus 9 equal to 23 minus 2x. Now we notice the difference between this one and the last one is that we have 2 terms that have x in it. So your goal should be to get all of your terms with x to one side of the equation, all of your terms without x to the other. It doesn't matter which one of these 4 terms you move first. As long as you do it correctly mathematically, you'll still get the same answer. So I'm going to go ahead and add 2x to both sides. 2x and negative 2x will cancel on the right. Then on the left, we have 7x plus 9. So then I will subtract 9 from both sides. And that will give me 7x equal to 14. And then to finish it off, divide both sides by 7. 7's cancel. And 14 divided by 7 is 2. All right, questions? Any questions? All right, next one. 8x minus 3 times the quantity of 4x minus 5 equal to negative 2x plus 6. First thing we want to do is remove those parentheses because we need access to this x term. So distribute negative 3 to both terms in the parentheses. So negative 3 times 4 is 12x, which is right here. And then negative 3 times negative 5 would be positive 15. Now, both of these x terms are on the same side, so we can go ahead and bring them together. Go ahead and add those together. Positive 8x and a negative 12x is this negative 4x right here. All right. So now we have negative 4x plus 15 equal to negative 2x plus 6. So now we're at that scenario again in which our goal is to get all of our terms with x on the one side of the equation, all of our terms without x to the other. So I'm going to add 4x to both sides. And that will leave me with 15 equal to 2x plus 6. Then I'll subtract 6 from both sides. That'll leave me with 9 equal to 2x, excuse me. Finish it off by dividing by 2. And x is equal to 9 over 2. All right, any questions? All right. Any questions before we go to the next one? All right, so this next one has fractions involved. So we're going to talk about how we can clear out the fractions because most people don't want to deal with fractions. So we can get rid of that by using this process. First thing we want to do is look at each denominator and find the LCD. So we're talking about this 4 and this 3. We want to know what's the LCD. Now, don't forget your LCD is the smallest number that each one can divide into evenly. Smallest number that each denominator can divide into evenly. So it's going to be 12. 12 is the smallest number that both 4 and 3 can divide into evenly. So we found the LCD. Then we're going to multiply each numerator by the LCD. Notice I didn't say top and bottom. I didn't say numerator and denominator. We're going to multiply across the equation. So we're going to multiply each numerator by the LCD. Even if it doesn't have a fraction or a denominator, we're still going to multiply by the LCD. Every term has to be affected by that LCD, or you're going to change the value of the equation. So you have to multiply each numerator by the LCD. And that's what we have there. Step 2, 12 times 3x over 4.
I'm sorry, could you scroll back up just a little bit because I'm trying to figure out what the initial equation was.
This is right here. Yeah. So you multiply 12 to each numerator. All right, any questions? All right, let me scroll up. All right, I don't know how far I can go up. Just let me know if I go up too far. Oh yeah, no problem. Not a problem at all. All right, so step 3 is to simplify. So, as I mentioned, we multiply each numerator by that LCD, multiply by 12. So now this 4 can divide into the 12 and leave us with 3. I think I will use purple. So that leave us with 3. 3 divides into 12, leave us with 4. All right, and let me erase this. Just want to write this down. So what would happen is you'll have 3 times 3x.
But you simplified with the 12, so you didn't like multiply nothing at all?
Now, what you saying? What are you asking? I want to make sure I got you right.
So over here at the top, so you know how you multiplied everything by the least common denominator.
Up here?
Yeah, you multiplied everything.
Yep.
But so instead of multiplying though, you just like kind of simplified, I guess.
Right. Right, because there are going to be situations where you may be dealing with larger numbers. Now, you can multiply. You're still going to get the same result. But what I did right here was before I multiplied the 12 to the 3x, I went ahead and divided the 4 into the 12. And that just leaves me with simple multiplication.
Okay. Then you just times the 3. Okay. I got you. Thank you.
Yep. Not a problem. Let's see if I had enough room to do what I was trying to do. All right, so probably need to bring that up some. Trying to make room because I just wanted to leave this step in here. I didn't do it before. All right, so when everything cancels, that's what you're left with. And then you have 9x minus 72 equal to 4x minus 12. So now at this point, your goal should be to get all of your terms with x to one side, all of your terms without x to the other. Doesn't matter which one you move first. I'm going to decide to minus the 4x from both sides. So the 4x cancel on the right. And that would leave me with 9x minus 4x, which is 5x, minus 72 equal to negative 12. Then I can add 72 to both sides. 72's cancel on the left, and that will leave me with 5x equal to 60. Then we can divide both sides by 5. And that'll leave us with 12 as a solution. All right, questions, any questions? All right, scrolling up, everybody good? All right, so let me walk through this. So here we have 2x minus 3 over 3 plus 1 over 2 equal to 5 over 6. And since we have fractions, it's the same thought process as to how we are going to handle this problem. You find the LCD, and you know we have 3, 2, and 6 as denominators. So that means our LCD would be 6, because 3, 2, and 6, the smallest number that all three of those can divide into is the number 6, because 6 can divide into itself as well. Then we're going to take that 6 and multiply it to each numerator. So this is what we have is 6 times 2x minus 3 over 3 plus 6 times 1 over 2 equal to 6 times 5 over 6. All right. Questions? Any questions? All right. So now we're going to simplify. 6 goes into 3, leaves you with a 2. 2 goes into 6, leaves you with 3. 6 goes into 6 and leaves you with just 1. So that'll be 2, 3, and 1 right here, as far as what's left. All right. Sorry about that. Sorry, yeah. Stuff keep messing up on me. All right. So now we can go ahead and distribute. So that'll give us 4x minus 6 plus 3, and then equal to 5, because 3 times 1 is 3, 1 times 5 is 5. Combine your like terms, a negative 6 plus a positive 3 would be negative 3. So you have 4x minus 3 equal to 5. Add 3 to both sides. 3's cancel. And that'll leave you a 4x equal to 8. Finish it off by dividing by 4. And x is equal to 2. All right. Questions? Any questions? All right. Questions? This right here is probably nothing. Somebody might have asked me a question specifically that day, so that's nothing. All right, let's go here. Solving for a specified variable. Clear out some of this stuff. So when you're talking about solving for specified variables, we have P equal to 2L plus 2W, and we want to solve for L. So when you have something like this, basically they want you to get that variable by itself, and more than likely you're not going to get a solid number as an answer. So, you know, in other words, when I go back here, we had x equal to 2. That's not going to be the case for these exercises. You may have, in this case, like you'll have L equal to P plus 2 over, you'll have an expression that your variable is set equal to, and versus a solid number as an answer. So solving for specified variable, we want to get that variable by itself. So our goal is to get L by itself. So you treat these variables as you would numbers. So that's what I was emphasizing right here. If I have 5 equal to 2L plus 7, and I wanted to solve for L, the first thing I would do is subtract 7 from both sides. So that's the same thing I would do here. I would subtract 2W from both sides. I want to get L by itself. So I move that 2W, that term, to the left side of the equation. And so I'm looking at P minus 2W equal to 2L. Once again, these variables represent numbers, so you treat them the same way you would treat numbers. They're just unknown. All right. So then, give that 2 back. You want to divide both sides by 2, because your goal still is to get 2, to get L by itself. 2's cancel, and the answer is L is equal to P minus 2W over 2. Now, before we look at reducing any further, anything like that, let's make sure we're okay with our answer being this. This is okay. This is fine for our final answer. But I know there are some people that's going to look at this 2 and try to cancel. You cannot do that. So I'll show you what you can do as far as trying to cancel, and then show you what you cannot do. So any questions on how we got here before we go anywhere else? All right, so bring your attention down here. We'll look at the incorrect way of reducing, and then we'll look at the correct way. So what a lot of people like to do is they want to cancel out this 2 and then write P minus W as an answer, and that way is incorrect. Okay, you can't just cancel out the 2 that way. This way up here is the correct way of handling the reducing. So that 2 in the denominator has to go into each numerator. So that's why you have right here P over 2 minus 2W over 2. Let me get that 2 back. And so once you're there, then if you want to cancel out the 2, you can do so. So these 2's will cancel, and that would leave you with P over 2 minus W. So both of those answers, this one or this one, are acceptable. Once again, you don't have to go this far. You could have left the answer like this and it would have been fine. But I just know that people try to cancel out stuff when they see common things, so I just want to make sure we do it properly. All right. Once again, do not have to do. All right, so you do not have to do. Now, next I'm going to show you a scenario in which you would have to reduce further, but in this case you did not. So before we go to the next thing, questions on what we did. I'll say did not. All right, so the scenario in which you do have to reduce further. And so notice it says if here. So it does not have to do any, it does not have anything to do with the problem we just did. This is just a scenario, a situation that you could be faced with. Notice that in this one, 2 can divide into this 2 here, and it can divide into this 4. Whenever you have that type of situation, you are expected to reduce further. If we look at the last one we were looking at, notice the 2 had nothing to divide into when we were looking at that P. So that's why you could leave it there with no problem, and this was a good enough answer. But I have a 4 here and a 2 here that 2 can divide into, so you are expected to reduce further. 4P over 2, and then 2W over 2 will reduce to 2P minus W, and that would be your most simplified answer. So if the number in the denominator can divide into each term in your numerator evenly, you are expected to reduce. All right, questions. All right, so next one, 5a minus 3b equal to 7. And we want to solve for a. So first thing I would do is add 3b to both sides. Your goal is to get a by itself. And so that'll leave you with 5a equal to 3b plus 7. Divide both sides by 5. And a is equal to 3b plus 5. 3b plus 7, excuse me, over 5. All right, questions. I think this is the last one out of this section. Yep. So here's this. All right, so here we have I equal to E over capital R plus lowercase r. Be careful when you go to put in your answers. Capital R and lowercase r are two different R's. So if you're solving for capital R, make sure you solve for capital R. And then if they want lowercase r in the answer or whatever the case may be, make sure you hold true to the integrity of your letters. If they give you capital, use capital. If they give you lowercase, use lowercase. And you'll be safe. All right, so we have capital R down here in our denominator. We need to get it out of the denominator. So the way we'll do that is multiply both sides by capital R plus lowercase r, that whole quantity. And so the whole quantity will cancel. And that will leave us with I times the quantity of capital R plus lowercase r. And it's equal to E on the right. E is over there by itself. I still need access to this capital R, but the parentheses are stopping that. So I'll distribute capital I. And this is what we have, capital R, well, capital I times capital R plus capital
Wait, why
I.
did you distribute capital R instead of distributing I?
I distributed I.
Oh,
Mm-hmm.
my
Yeah.
bad. To do
Oh, no,
that.
you're fine. You're fine. If I may have
Right.
said it wrong. Say again.
I said I should be looking. I'm over here just writing.
Oh, that's all good. I may have said it wrong. If I said it wrong, then that's my bad as well. So it's all good. I'd rather you ask than, just like, oh, well, I don't know what you talking about. Nah, yeah, that's good. That's all good. So distribute capital I. So I times R plus I times R, capital and then lowercase. And that's equal to E. And once again, your goal is to get capital R by itself. So we need to move this lowercase r and I. And we'll do that by subtracting the two. Well, that's one term. And so that'll take us over here. That'll be capital I times capital R equal to E minus I lowercase r. And then we can finish it off by dividing by capital I. And that's capital R is equal to E minus I R over I. And that lowercase r is on the right side. All right. Questions? Any questions? All right, let me see something real quick. Rate ratios and proportions. Percents. How much of percents are in here? All right. See how much is over here. Cross multiplication. Oh, this is short. Okay, let's do sum of 9.2. I'm not saying we're gonna finish it, but 9.2 isn't heavy in content, so we might be all right with that. So let's look at rate, ratios, and proportions. So your rates, comparison of two quantities, can be written as a fraction. So 135 miles over 6 gallons is considered a rate. The division sign is also represented as far as words as per. So 135 per 6, 135 miles per 6 gallons, or 135 miles for every 6 gallons. Your unit rate is a rate in which the denominator is 1. So if I wanted to find a unit rate of this expression, of this rate, I would just take 6 and divide it into 135. And that's 22.1, 22.5, excuse me. So that would be 22.5 miles for every 1 gallon, or in other words, 22.5 miles per gallon. All right, any questions? All right, so a dental hygienist earns $1,304 for working a 40-hour week. What is the hygienist hourly rate of pay? So you want to know dollars per hour. So you put that 1304 over 40, $1,304 every 40 hours. You will go ahead and divide that. Throw it in the calculator, 1304 divided by 40. Convert that to a unit rate. So if you want to know how much he or she makes per hour, it didn't say if it was he, right? But she. So that's $32.60 per hour. And yeah, that's all there is to it. All right, any questions? All right. So the next one, which is the more economical purchase? An 18-ounce jar of peanut butter, priced at $2.69, or a 28-ounce jar of peanut butter, priced at $3.99. So we want to know the cost per ounce. So it means dollars over ounce. That'll be the best way to compare both of these purchases. How much are you paying per ounce? So the first one, we take the $2.69, place it over 18 ounces. So you're paying 0.149 cent per ounce. Then the next one, $3.99 divided by 28, and that's 0.143 per ounce. So the $3.99 purchase is the one that's the more economical price or economical purchase because you're paying less per ounce. All right, questions on that one? All right, ratios, the comparison of two quantities that have the same units, can be written three different ways. As a fraction, with a colon, or with two. So that's 2/3, 2:3, or 2:3. All of those represent the same ratio. All right, let me erase some of this stuff. So we have a survey revealed that on average, eighth
Can you
graders
go back up
watch.
some?
How far up?
Right there.
Okay. All right. A survey revealed that on average, eighth graders watch approximately, that's APP, approximately 21 hours of TV each week. Okay, better. Find the ratio as a fraction in simplest form. All right, can I scroll up? Of the numbers of hours spent, let me erase this stuff, watching TV to the number of hours in a week. So we want to look at or find a ratio for the number of hours spent watching TV to the total number of hours in a week. All right, so if you want to look for, find the number of hours in a week, because you look at what we have here. It says find the ratio as the fraction in simplest form of the number of hours spent watching TV. And then it says 2 here, so 2 is where we're setting up our fraction. Everything to the left of that 2 is my numerator, tells what to put on top. Everything after that is what goes on bottom. So if you're talking about the total number of hours in a week, it's 24 hours in a day, 7 days in a week. So multiply those together, and that'll give us 1.6. I said 1.6, 168, 168 hours. All right. And we already knew the number of hours in a week. They gave us that number, which was 21. Number of hours in a week that they spend watching TV. Sorry about that. Number of hours in a week they spend watching TV is just 21. So that's 21 over 168. 21 can actually cancel out into 168 and give us the most simplified fraction of 1 over 8. All right. Questions? Any questions? All right, can I scroll up? Just like the unit rate, a unit ratio is when the number of the denominator is 1. And blowing hard. All right, so looking at this next one, they give us a mini chart. Give us a university. I believe that's Oregon State University, and then the University of Oregon, OSU, and then UO. And they give us the number of men, number of women, and then the number of faculty. So talking about men students, women students, and then faculty. And so it says calculate the student faculty ratio at OSU. So make sure you pay attention to which college they're talking about. At OSU, round to the nearest whole number and write the word 2. Right, using the word 2. So this time they don't want a fraction. They want you to write the ratio using the word 2. So we're looking at student to faculty ratio, student dash faculty, student faculty ratio. So the number of students that we have totally is right here. You would take the 10,018, add it to the 8459. That gives us 18,477. And so student to faculty is going to get 18,477 over the 1471. Divide that out. Remember, we were talking about unit ratios. Divide that out, you'll get 12.56. And that's where they were talking about round to the nearest whole number. So you round that 1256 to 13. So that means there's a 13-to-1 ratio student to faculty. All right, any questions? All right. Last thing in this section, proportions. It's a statement that says that two ratios or rates are equal. So 2/3 is equal to 12 over 18, or 2 over 3 is equal to 12 over 18. So that is a proportion. You have two fractions, two ratios or two rates that are set equal to each other. So the relationship that we will be using with these proportions is cross products. A over B is equal to C over D. If that's the case, then that means A times D is also going to be equal to B times C. So you take your denominators up to the opposite numerator. And once you do that, if it truly forms a proportion, those two numbers are supposed to be equal. So if you go back to our example right here, 2/3 equal to 12/18. We were to cross multiply, that's 2 times 18, 3 times 12, and so 36 is equal to 36. All right, questions? Any questions? All right, so we're going to use the start process to solve. If we have 8 over 5 equal to n over 6, so cross multiply. Take the 6 up to the 8, 5 up to the n. 8 times 6 is 48, 5 times n is 5n. Then just divide by 5. 48 divided by 5 is 9.6. Any questions? Next one, you travel 290 miles per hour. I said miles per hour, 290 miles in your car on 15 gallons of gas. How far can you travel on 12 gallons of gas under similar driving conditions? right, so you want to set up your proportion and make sure you stay consistent throughout your proportion. And so what I mean by that is that I chose to set it up, hit the wrong button. I chose to set up my proportion as miles over gas. If you wanted to do gas over miles, you still could as long as you stay consistent. Also, another way of dealing with it, there are different ways of dealing with it. Just whatever you want to do is you want to stay consistent in what you're doing. So I chose miles over gallon. So when I look at, I have my original relationship or 290 miles and 15 gallons. So I put my 290 over 15. Then my other relationship, how far can you travel? So in other words, how many miles on 12 gallons of gas? So that's why I have X over 12 over here. Like I said, as long as you stay consistent, I decided to do across the board miles and then gallons on the bottom. All right. So once you have your proportion set up, you can go ahead and cross multiply. So that'd be 12 times 290, 15 times X. That'd be 3480 equal to 15X. Then you divide by 15, and that'll be 232. So you can travel 232 miles on 12 gallons of gas. Questions? Any questions? Let's scroll up. All right. And this last one, yeah. All right. So here, same type of thought process. We have the dosage for a certain medication is 2 ounces for every 50 pounds of body weight. How many ounces of this medication are required for a person who weighs 175 pounds? All right. So once again, you look at your initial relationship is ounces to pounds. So it says 2 ounces for every 50 pounds of body weight. So I decided to set my relationship up as ounce over pounds. You want to do pounds over ounces, feel free. Whatever you do, you have to stay consistent throughout your proportion. So I did 2 over 50. Now when I go to the next one, it says how many ounces is required for a person who weighs 175 pounds. So if I keep up with ounces over pounds, that means X is going to be my ounce, my unknown. Pounds is 175. All right. Any questions on this setup?
You go back up an inch.
All right. So now we cross multiply.
Can you scroll back up an inch?
All right.
Keep going. Sorry. See that box from the last equation. I'm trying to see that box from the last equation. The red.
Oh, this wasn't anything. You talking about that? Or are you talking about this box?
The one you just put like a squiggly line through.
Oh, okay. Well, yeah, you wanted to I didn't talk about that. It was just me reducing. Let me see, where did that even come from? Oh, that was me reducing without a calculator. Probably something that somebody asked me about. I mean, you can copy it if you want.
Okay, I'm good.
Okay. Probably something like I said, somebody asked me about from your previous class. Mhm. All right, let me know when I can scroll up. All right, are we good to scroll up? All right, at least I know we're good right there. So taking that 2 over 50 equal to x over 175 and cross multiply. So that'll be 2 times the 175 and 50 times x. All right, so 2 times 175 is 350. Divide both sides for that 50. And x is equal to 7. So 175-pound person requires 7 ounces of this medication. All right, questions on anything? Any questions? All right. So, as with always, it's always important that you try the stuff out. See if you get stuck on anything, and bring the questions either to class or shoot me that email, and we can discuss what you got going on. So, outside of that, if you guys are good and I'm good, try the stuff out, and I will see you guys on next class. You guys have a good one.
Thank you.
Thank you. You have a good one. Take care. Thank you.
What day is Unit 7 due again?
Say
Have a
again.
nice February 21st. Okay, have a nice day.
You do the same. What was your question, sir?
My question was what day Unit 7 was due, but she answered it.
I don't even. What did I say? What did she say? What was it?
February 21st.
February 21st. Yeah, I'm probably gonna move that. Probably move it to
March 1st.
yes, something like that. We'll see. We'll talk about it some more though. I think I'm
All
gonna move it just because some people still had issues getting into Blackboard. So right now that I don't even think I changed it in WebAssign yet anyway. So
Okay.
yeah, right now it's still in flux. So you all right?
All right, thank you.
Yep, not a problem.